Am I audible?
Good morning, sir. Yes, sir, you're audible.
Okay. Okay. So I guess I would just like to remind you that you need to share the details about your partner and the title of the project very soon. So that deadline should be there. Let me just quickly see when it is due.
Sir, both the partners have to fill in separately, or
No,
one?
one of you could just fill in. There is no need for both of you to fill that in.
Right.
So yeah, so 3rd February, Thursday, 5 p.m. So in the next 2 days, you have to decide your partner, and I mean you should have already decided, hopefully, because your midterm report will be due in a week, so February 9th. And I have already said what are my expectations about that midterm report, and then you will have um, the presentation probably on February 10th. So earlier I was planning to have it on February 11th, but it seems that we will have to do it on February 10th. So I will make another announcement related to that sometime later. Okay, so midterm report is due on February 9th and presentation will be scheduled on February 10th. Okay. Okay, so that is about the project. So any quick question about the project? Okay. Okay, so now let's look into this topic of wireless network security. Okay, so first let's see what are these different types of wireless networks that are present uh, in so currently, and I guess most of us are already using all these different types of wireless networks. Okay, so the most common one is, of course, cellular. So we are already using 4G, and 5G is just knocking on the doors. So what I have done is I have highlighted some key characteristics of these wireless networks. So in terms of power, in terms of coverage area, and in terms of the data rate that it provides. So the rate of communication that is provided by this wireless protocol. So you see that these towers are related to cellular communication. So you might be seeing a tower in every kilometer or so. Okay, so these because they cover around a kilometer of area, that's why we call it a wide area wireless network. Um, and then they communicate at a very high power. So our smartphones, so they are considered a powerful devices. So they are running um, sometimes multi-core processors and very powerful RAM these days, uh, going into few GBs, and therefore they are called high power. And the transmission power is also very high. And of course, we are able to see live videos and stream videos very conveniently on these cellular networks, and therefore they are high data rate as well. Okay, so now let's look into another protocol that we use very often. So the Wi-Fi network, and there it is low power. So you see that the area in which a Wi-Fi access point can provide service is very limited, probably a few meters. So ideally it should go up to 100 meters, but it is not very useful after 10 meters or 20 meters. Okay, so local area, so very small, just within a house or within an apartment service, low power, and because it is low power, it is so local area but high data rate. Okay, so you are able to stream a video on Wi-Fi. So it is high data rate, it is local area, and it is low power. So these three things are correlated. So if you see all these different wireless networks, you will see some correlation between them. Okay, so now let's move to the another one, Bluetooth. So all of us are definitely using Bluetooth. So there it is again a low power wireless communication protocol. It is again local area, so very small area, probably a few meters. And then, but unlike Wi-Fi, it is low data rate. So you cannot probably stream a video on Bluetooth, but you can always hear music on Bluetooth or communicate a small amount of data on Bluetooth with some kilobit per second rate. Okay, so then we have another type of communication which is getting popular very recently. So there are now many real world deployments of this wireless network. So they are LoRa, Sigfox, narrowband, IoT, so Internet of Things. So this just means Internet of Things. So there you have low power, you have low data rate. So this is something which is this type of wireless network supports sensors. So for instance, if you want to put in something like a pollution measurement sensor, so that does not require any communication of video or so. So it is very small amount of data that has to be communicated. And then you would ideally want to cover a very large area and then have a one base station or some central unit which will collect all the data. So it has to be wide area. It could be low data rate and it could be low power as well. Okay, so these are some different characteristics as compared to the other protocols that we just discussed, the other cellular, Wi-Fi and Bluetooth. So yeah, so you could think of air pollution measurement as a very concrete example of one of these protocols. Okay, and then satellite. So if you are using GPS, of course, we are using GPS. So we are using some sort of satellite communication. And if you are watching TV, you are also using some sort of satellite communication. So in that case, we have very, very high power that is being communicated, very wide area. So just one satellite is able to cover hundreds and thousands of kilometers of area, and then very high data rate. So the data rate is also very high in those scenarios. Okay, so these are different types of wireless networks that are present, ranging from high power to low power, wide area, a very wide area to local area, and then very low data rate to very high data rate. Okay. So any quick question about this different variety of wireless networks?
Power is the power of the device that is using it.
So it is very correlated. So basically, when we say about this power, we are referring to the you could think of the power at which the analog signals are broadcasted or transmitted at the physical layer. Okay, so if you look into the protocol stack, so when we talk about power, we are talking about the last layer, the bottommost layer, physical layer, and there in order to broadcast these type of wireless signals, you will have an antenna, and then that antenna actually sends these signals over the air with certain transmission power. Okay, so it could be from a few milliwatt to around hundreds of milliwatts, and then up to probably 1 watt or so. Okay, so that is the range of power at which the wireless signals are transmitted. So when we say power, we are typically referring to that power. but that power at which the transmission happens is very correlated to the device or the power that your device is getting. So if the source of power to your device is a battery, um, then you are probably going to use very small power to transmit signal. But if the source of your power is something else, and you are connected to electricity all the time, then you can probably use higher power. And of course, in many of these scenarios, so if you are using a Bluetooth device, many of these Bluetooth devices are battery powered. So you will be using low power to transmit signals. So if you are using, so although you have your phone, which is battery powered, but it has a very large battery. So you could use high power to transmit the signals. And for wireless access points, the issue is that you are connecting many devices, and the area is at which you have to serve the different devices has to be very small. So therefore you transmit with low power. You cannot transmit with high power, because otherwise it will start interfering with the Wi-Fi signals of your neighbor. So therefore you want to transmit at a low power. So yeah, so these are many different types of trade-offs which are based on the application for which the wireless network is being designed. So you first think about the application, and then you think about the type of wireless network that you will utilize in that scenario. Okay. Okay, so now that we have looked into this variety of wireless networks, so we will look into some you can think of the threat model for these different wireless networks. Okay, so in this threat model, we are trying to look into what the adversary could do. Okay, so the adversary is looking at this wireless channel. So like any other receiver, the adversary could also very easily receive all the transmitted signals. Okay, so it is at least for the wired networks, the adversary has to find out a wire and then get connected to that wire. But in the wireless signals, it is very easy. So if you are in the communication range of the transmitter, then you will be able to receive all the signals sent by the transmitter. So then the attacker, so therefore these wireless networks are susceptible to eavesdropping. And then there is one other type of attack which is very specific to wireless networks, unlike wired networks, which is called jamming. So jamming here means that the transmitter, the benign transmitter, wireless transmitter, is sending signals at a particular power. Okay, so it is probably using, let's say, 100 milliwatt of power to transmit its analog signals over the air. But what the attacker could do is, it could send some noisy signals at very high power. So let's say 1 watt or 10 watts of signals. So then, so if you have a benign transmitter, so let's say BT, and then you have this attacker, and then you have this receiver. So if ideally the receiver should have received this wireless signal with when the power is only 10 milliwatt from the sender. But if the attacker sends something with a very high power, let's say 1 watt power, which is 100 times more than the power of the benign transmitter, then what do you think the receiver will receive? It will receive whatever the attacker wants to send to it, that noisy signal, and it will not be able to figure out what this BT, the sender, is actually trying to, benign transmitter is trying to send. Okay, so this is just from a very high level perspective. From if you are looking into the signal processing aspect, so what happens is that if on the y-axis we have the signal power, and on the x-axis, let's say it is time. So a benign signal probably will look something like that. So the signal is being transmitted on the and to the receiver. The sender is transmitting to the receiver. And now, if there is a noisy signal which is 100 times more powerful than the benign signal, then what the receiver will see? It will see something like this. So, so this is the attacker signal. Okay, so this is the attacker signal. This is the benign transmitter signal. So again, if you think about this type of superposition for the receiver, the attacker signal becomes the main signal, and this benign signal becomes just the noise. So the receiver will not be able to make out what the sender is going to send, and that is what is called jamming. So what the attacker has been able to do is it has been able to overshadow the signal that is being sent by the sender. Okay. Okay, so that is one type of attack, but the other vulnerability with the wireless devices are because they are portable and mobile. Okay, so when you have, let's say you want to um, uh, probably secure a device like a desktop, which is not mobile. So there could be some things that you could do with that environment in which the desktop is put. But when you have these wireless devices which are mobile, then you have to think about different security issues. So for instance, if a desktop is connected to a particular network, it will always remain connected to that particular network. So the IP address will have certain structure to it. Those things are not going to change. Its location is not going to change. So it is fine. But if you have a mobile phone, if you are in a particular location, you are connected to one base station, one other the system that is put on a tower that is installed in that area, and then you move to another city, and then you are connected to some other base station, some other cellular tower. So because of this mobility, you cannot have very similar security solution that you could have for wired or for devices which are stationary. Then again, in terms of resources, these wireless devices in many cases have limited memory and limited processing resources. So if you think of a Bluetooth device, which is operated using a very small battery, these restrictions are always there for it. And then accessibility, that is also something which is very important. So I gave you an example of air pollution monitoring devices. So let's say you put it on some buildings, on the top of some buildings, or on the top of traffic lights, or probably street lights. So if you put all of those your air quality measurement sensors on those things, then you are actually leaving it unattended. So the entity which is putting all this, or the let's say the admin who is putting all these different wireless devices, they do not have control over these devices 24/7. So for instance, if we have a mobile phone, although it is a wireless device, it is with us all the time. So it is not that we are leaving it unattended. But if you think about some other type of wireless devices, many times we leave it unattended. So specifically those which are being utilized for IoT these days. So these are different issues related to wireless devices which are probably not so visible in the wired domain, and that is why I wanted to highlight these things. Okay, any question related to these different issues in the wireless environment?
Sir?
Yes.
in the case of jamming, sir, to overshadow the means the intended signal which is getting transmitted between sender and receiver, the attacker should send the signal at the same frequency with high amplitude. No?
Yes. Yes, that is correct.
Sir, I think I missed to understand that why limited memory is a vulnerability.
Mm-hmm. Yeah. So think about RSA. Okay, so if you this time we have not actually looked into the storage requirement for a particular algorithm. So if you try to look into the storage requirement for a particular algorithm, so for AES, I had actually shown you some video if I remember correctly. So there you need a substitution block, and then so that table has to be stored somewhere so that you could refer to that table and then do the substitution. Similar things for running RSA, you need a variety of parameters that has to be stored. So if you have been running it on a computer, it is not a problem. But if think about running it on a device which has only kilobytes of memory. Okay, so if in future you have an opportunity to work on any Arduino boards, Arduino, so you must have heard about these simple things that people implement using these Arduino boards, simple lighting system and those kind of things. You will realize that they have very, very limited memory, so only a few kilobyte of memory. So if you just write, so it is very, very difficult for them to even implement symmetry key based crypto, which requires some memory. But if you try to implement something which is asymmetry key based, you will realize that with the limited resources, which means computational resource, communication resource, and storage resource, you might not be able to implement an asymmetry key based cryptography. So because these kind of resource limitations limit you from using some cryptographic algorithms, so then you would not be able to implement many of these cryptographic algorithms in such scenarios. And when you could not implement these standard or conventional crypto algorithms which are utilized, which are very popular in conventional computer networks, then what will you do? You will use either something which is unconventional, which is very specific to a particular device or very specific to a particular application, or you will try to get rid of that part. So if you, let's say, if you buy any Bluetooth device, so you have to do pairing. Okay, so in order to make sure that you share a secret key with the that Bluetooth device, and so you pairing between smartphone and that Bluetooth device. So what happens during that pairing, that you share a secret key with that Bluetooth device. So why do you have to do such kind of pairing? Because the Bluetooth device does not implement any asymmetric key based cryptography. So therefore you have to do this kind of pairing in order to make sure that a symmetric key is shared so that the following communication will remain secure. So the constraint of resources on that Bluetooth device has forced you to use something new, which is called pairing. Okay, so then when these Bluetooth devices were introduced in early 2000s, pairing was utilized, and thereafter for years it has been shown that there is this kind of vulnerability in pairing, there is that kind of vulnerability in pairing, and even until 3-4 years ago, the people were looking into security issues in pairing. And so this idea of having pairing is good, but then it introduces many new security vulnerabilities which were not present if you would have just gone ahead with this asymmetric key based key agreement protocols, which were which are very popular in computer networks. So these, so if you have constraints in resources, then you will opt for options which might lead to security vulnerabilities. Okay, so I hope that relationship is now clear.
Yes, sir. Yes, sir.
Okay, so one of you had actually talked about an evil twin attack sometime, and this is a very, I would say, conventional attack. So it has been there for years, and people have been using it in different variations, but in all variations, things could be traced back to this attack, which is called evil twin attack. Okay, so as the name suggests, so you have two devices. Okay, so one is a benign device and one is an evil or attacker's device. Okay, so one is now in wireless setup, so you could have this scenario in many different cases. So here what we have talked about is a particular example of evil twin attack on Wi-Fi access point. Okay, so then what are we referring to? So you will have one access point, let's say your home wireless network. So you might have a router which you would have placed in your home, and then your Wi-Fi name, which is typically referred to SSID. So that you would have set up as something, my home or something, and then you would have a corresponding password. So what the attacker would do, a malicious attacker, it will set up a malicious access point near your house. Okay, so that is the evil twin. And then it will utilize the same SSID as the benign access point is using. So now every receiver or the legitimate access point is using. So now every receiver will have both these SSIDs, or because those SSIDs are same, so it is possible that some receiver actually gets connected with that malicious access point. And then if there are some security issues or security vulnerabilities in that particular receiver or that particular device which got connected to the malicious access point, then that through that malicious access point, the attacker would be able to exploit those security vulnerabilities. Okay, so few things that the access point will need to do in order to take control of at least a few devices or enforce a few devices to get connected to that malicious access point would be that transmit with higher power. Okay, so this is very, very common technique, which means that so if you see the list of SSIDs whenever you have any device and you switch on the Wi-Fi signal, so you will see them in typically by default in the order of the signal strength. So the strongest signal strength will be at the top and the weakest one will be at the bottom. So ideally, if you are close to some access point, you should receive a very strong signal. And in order to, but note that your access point will be inside your house. The attacker's access point will be somewhere outside your house. And if there is a device inside your house, then the strongest signal should have been coming from the benign access point or legitimate access point. But in order to evade that part, what the attacker could do is transmit with a much higher power than a regular access point. So the regular access point's power will be limited to a few milliwatt, but for the attacker, there is no limitation like that. So the attacker could transmit at any power. And therefore, when it transmits at a high power, then it is highly likely that the device, the target, will associate with this malicious access point, which is sending these signals with the very high power. Okay, and then after getting connected, it can do many things like intercept just the traffic or replace some data or try to harvest some credentials. Okay. Okay, so any quick question about this evil twin attack?
It is assumed that the access point which is transmitting at a higher power, it will know the password also of the actual.
No, it will not know the password. It cannot know the password. But do you think that the attacker will ask? So it can actually ask you for the password, but it will not do any verification. So let's say that you see the same SSID. Okay, so you try to get connected, and then it says that oh no, you forgot the password. Please re-enter the password. Okay, so then on your device you re-enter the password, and then where the verification is going to happen for that password? At the access point. So if it is the attacker's access point, what is it that it is going to do? So of course, if the password is being transmitted in plain text, it is another matter, but that typically doesn't happen. It is sent in an encrypted form. So it will, even that encrypted form will be captured by the access point and will not do any verification. It will let you access the internet through it. Okay, so without even doing any password verification.
Like nowadays, this attack is possible on our mobile devices. Like if I create a access point with my with another mobile phone using a hotspot and have the same name Wi-Fi is having. So I mean, possible, or there is some.
No, so there are two things. One is that whether you will get auto connected to that access point, and then things will happen automatically or not. So the thing is that with the current systems, you will not automatically get connected to an access point or an SSID which has the same SSID with which you were connected earlier. So this automatic connection will not happen. So you will be asked to enter a password or something, or you will be asked to connect to this access point. So if you go ahead and connect to that access point, then there is nothing that could be done. So this automatic connection is not possible these days, but it is possible that if you click on it, I mean, you could get connected to a wireless access point just by a click on your mobile phone. So if you do that click, then yeah, you are connected to it. So now once you get connected to it, then what are the capabilities of the attacker? So that is the thing. So with our mobile devices, our mobile phones, the attacker after getting connected, the access point after getting connected, so it has very limited things, because we have been talking about TLS, and there are many other security protocols which are also utilized at different layers in a wireless protocol stack. So if you have all those, then the things that the attacker will be able to do are very limited. So of course it could intercept the traffic, probably try to do some traffic analysis. It will try to send you messages which can mislead you, but whatever is being encrypted at your end, it cannot be decrypted by the attacker. So that is something that is provided by the existing security protocols. But since you are communicating through that access point, a few things can always be done by that access point.
Sure, sir. Thank you, sir.
Okay, any other question?
Sir, is there any mitigation for such kind of power attacks? Like in other networks, I have heard of some frequency hopping kind of thing is employed. So is it possible in the wireless networks also? like Wi-Fi?
No, frequency
mobile?
hopping happens in a wireless network. So that is a type of defense against jamming attacks. So yeah, we are not going to discuss about those things. So yes, so although these attacks are there, so there are defense mechanisms as well, and those defense mechanisms are applicable only in certain scenarios. So unlike our crypto algorithms, so as I have said that when you have to actually provide encryption or authentication property to a single message going from a sender to a receiver, then you could use our crypto primitives and you will be good. You will be able to provide encryption, you will be able to provide authentication, that's fine. But when it comes to a protocol, when a message has to go from let's say two entities and one, so let's say client and server, the client becomes the sender, the server becomes the receiver, and then after some time the server becomes the sender, the client becomes the receiver, and this communication happens, and that becomes a security protocol. So when you have this protocol, so it's not just one message, it's a sequence of messages, then ensuring the security of the protocol is a very, very challenging task. And jamming is an attack which is very successful in certain scenarios. So there are some defense mechanisms, like as you mentioned, frequency hopping is one way of preventing jamming, but it is effective only under certain conditions. So I will not want to discuss those conditions, but I just want to highlight that it is unlike the crypto-based defenses, where you say that the level of security is, if you are using 128-bit key, the level of security will be 128 bits, which means that the probability with which the attacker will be able to break the encryption will be 2 raised to the power minus 128, which is very, very small. So there, these fundamental guarantees are there, and no matter where we utilize that encryption. So when you're using a crypto-based solutions, you have those fundamental guarantees, but when it comes to protocol, those fundamental guarantees are not there. And then similar things can be said about jamming. So jamming, there are defenses utilized to mitigate jamming, but you cannot have similar guarantees. So in some scenario, you will have defense against attacker which can transmit up till, let's say, 1 watt of power, so something like that. But if you have an attacker which can transmit up to 10 watt of power, then your defense will not work. So you may have some frequency hopping, which means that the frequency of the transmitter is changing the frequency at which it is sending the packets. So if you are sending, if you are changing your frequency, let's say among 10 possible frequencies. So if the attacker could jam only one frequency, then you have defense. So the other 9 will be available for you to communicate your message to the receiver. But think about the attacker which is more powerful, which could jam all your 10 frequencies. Then there is, although you could utilize frequency hopping among those 10 frequency channels, but there is no point in doing that because the attacker is already jamming all 10 of them. So what I'm trying to highlight here is that there are defenses, but the defenses are very scenario specific. It depends on the ability of the attacker. And yeah, so I guess that is what I wanted to highlight. So these things are still as part of research. So if you see the literature, there are still papers which are being published to prevent jamming. This means that it is not a problem which has already been solved. Okay. Okay.
So, sir, as the application developer, don't we have to consider all these kind of security protocol vulnerabilities?
Yes, you have to consider all of that. So so that is why when we started this course, we talked about what are the security properties you need to provide and what is your threat model. So what kind of adversary you are looking at while developing your defense mechanism. So you will have to think about when designing a security protocol or when designing a system, what is the adversary against which you are trying to make your system secure. So you cannot design a system which will be, so for instance, and I probably gave you a lot of examples. So one quick example will be that if you are coming up with a system which is going to be there for next 4 or 5 years, but after that it is not going to be there. So you know that quantum computers are going to come, and the quantum computers will be able to break RSA encryption. So should I use RSA encryption or not use RSA encryption? So that is the choice that you have. So now that you know that your system is not going to be there probably after 5 years, then you can take a chance that, okay, so let's just go with RSA encryption, because anyway, the quantum computers, even if they could be developed, it is possible that in the next 5 years, very highly likely that they may not be so advanced as to break RSA encryption, but in 10 years they might break it. So if you are designing a system which is going to be there for 20 years, then you should definitely think about post-quantum cryptography and utilize that quantum cryptography. So we talked about all these things. So yes, we have to think about the threat model before designing your system.
Okay, sir.
Okay. So okay, so let's look into some of the things which are done in a wireless setting. So specifically, we are looking into a setup of you can think of a Wi-Fi access point communicating with your smartphone or any device which is placed in that local area network. So there, so this is local area network LAN. Okay, so there is a standard called IEEE 802.11i, which refers to wireless LAN security, and that standard has been revised multiple times. So the first version of this standard came with an algorithm which was called wired equivalent privacy, because this is something which was, this is something that you have to do in addition to whatever you do in a wired communication network. So, okay, so if my desktop is connected to a wired LAN, so there are a few security protocols that are already running on different layers. So for instance, we talked about TLS. So TLS is already running. So even if you're utilizing your mobile phone connected to a Wi-Fi access point, so the TLS is anyway going to be there. So what is it that you need to do in addition to that in order to mitigate vulnerabilities which are specific to wireless networks? So this is that is why you have this separate standard for wireless security. So the first name as is now evident why it was called wired equivalent privacy, WEP algorithm. Okay, so that was the first version. Of course, every version has some type of vulnerability. It is about just finding that vulnerability. So it stayed there for a few years, but people started finding major weaknesses in that algorithm. And so we will briefly talk about what major weakness they found in a minute. So in the next slide. So since people found that out, so they came up with an advanced version. So they came up with which is called Wi-Fi protected access, so WPA, and then it utilized something called temporal key integrity protocol, so TKIP. So if you ever got a chance to configure your Wi-Fi access point as an admin, so you would have seen these terms. So WPA, TKIP, you would have, if you try to configure the security of it, you will see these terms in there. So then, yeah, so some vulnerabilities were found in that updated version as well, but it was definitely something which stayed there for quite a few years. So it was not something like WEP, which was cracked very, very soon. So then came WPA2, and this is considered secure, but there are newer versions of wireless LAN security as well. So with WPA2, some additions have already been done. And when you try to configure, so with WPA2, you might get a message that you can do these additional things as well in order to enhance your security. So this one thing that I want to highlight is that it uses the CCM mode. So we have not used this CCM mode, but basically CCM is very similar to utilizing cipher blockchaining for encryption, and then so for counter mode for encryption, and then cipher block chaining for authentication, for generating message authentication code. So mixture of counter mode and cipher block chain. So this CCM mode is another mode of doing authenticated encryption. So you have already implemented GCM mode, which is a more advanced version of doing or much faster version of doing authenticated encryption. So CCM is, you can say, comparatively slower or worse in terms of execution time as compared to GCM. So therefore, I did not ask you to implement CCM, but CCM is also with a protocol which was very popular just a few years ago. Okay. Okay, so these are some of the things that I wanted to tell about this history of wireless security, wireless LAN security. Any quick question about this history? Okay, so very quickly, what are the different steps in the communication or in the secure communication in a wireless setting? So we would like to just quickly discuss about those different steps, different phases. Okay, so you have these different entities. So you have a station. So let's say client, and then you have some end station. So let's say the server. So so you have your laptop here, and then you probably trying to access YouTube server or something. Okay, so that is what this station and end station refer to. And then you have an access point. So this is something which is in addition to what you could have seen in a wired setting. So this access point is something which is specific to a wireless setting. So there, this access point will have to do in the first phase. What is it that it has to do? It has to do the discovery. So this station has to first get connected to this access point, and then and in order to do that, it has to go through this process of discovery. So this access point must discover this station and get connected to it. Okay, so that is the phase one. Okay, so then comes the second phase. So there is an authentication server. Okay, so if you are connected into our IITD's network of this access points, then you will have an authentication server set up by IIT Delhi, which will authenticate whether you could get internet access through that access point or not. Okay, so this second phase is about authentication, and then you could probably do some key agreement after connecting with that authentication server. And once you have that authentication or authenticated ticket with you, then you could utilize that ticket to actually start doing secure communication with the server. So this STA will start doing secure communication with the end station, and then of course at the end there will be some connection termination. So these are some of the steps which we have also talked about in terms of other protocols. So there are slight or subtle differences because of this wireless nature, and those are most importantly, the one which is related to the phase 1 discovery. So that is something which is very, very different in a wired environment and in a wireless environment. So discovery of the device in itself is a research problem, and people have been looking at it, and there are some good solutions as well which are implemented in the real world, but of course people are improving upon it as the time progresses. So any quick question about these different phases of communication in a wireless network?
So this is applicable to all kinds of wireless networks, right?
Yes, so you could typically generalize it to any type of wireless network. That is why I do not want to just say that we are talking about our Wi-Fi. So I do not want to restrict this kind of discussion to that. So although the terminology that is being utilized is all related to our LAN, wireless LAN, but you could have the same setup in other scenarios as well, in other wireless networks as well. So it's just that the terminology might be different. Yes, Pankaj.
Sir, there's a quick question. Sir, when we talk about this phase 2 and phase 3, so sir, are these communication stateful?
Are these communication?
Stateful. I mean, how does AS distinguishes between two different uh, requests from two different sources? So, I mean, is this also taken care? So, I mean, like stateless, stateful.
No. So see, at least in this case, what will happen is that when a station gets connected to an access point, it gets an IP address, it gets a unique identifiable ID, which could be utilized by this station to get authenticated by this authentication server. So because this discovery or the communication is being started by first connecting with the access point, and then the access point is also connected to the authentication server. It's not that the access point is it is just not being shown here, but the access point is always connected to the authentication server. So this station will get a unique identity which it could utilize to uniquely get some authentication tickets from this authentication server.
Got it, sir.
Okay, so I spent a lot of time in discussion today. Okay, it's fine, I guess. Okay, so I will quick talk about this WEP cracking attack. Okay, so this is very interesting, and therefore I wanted to talk about it in a little bit more detail. Okay, so this was the first version. So wireless equivalent privacy algorithm. So this was the first version which was utilized for wireless security, and this version had a flaw. And as I have been saying that if you if you just have one message and if you want to encrypt, if the sender wants to encrypt it, send to the receiver, there is no problem typically. You have some standard cryptographic algorithms which will be able to provide you the security. But when it comes to multiple messages, multiple exchange of messages, that is where the problem starts. Okay, so we know that RC4 is a stream cipher which could be utilized for doing encryption, and it could be done very securely. Okay, but for one message it is fine, but if there are multiple messages, then how do you utilize this stream cipher becomes very, very important. And what was happening in WEP was, so let me just quickly talk about it first and then tell you the attack. So WEP did this encryption using a secret key, so a symmetric key, and then that symmetric key is shared between the stations through some technique. Okay, so out of band technique, and the encryption algorithm was RC4. So very standard setup. One secret key is there, symmetric key, and the stream cipher for encryption is going to be RC4. So very standard setup. And then, of course, because you will be utilizing a large number of messages and and you would like to encrypt them with the same secret key. So therefore, you will utilize an initialization vector IV, and then okay, so and then the combination of the IV and the key will be utilized to do the encryption. So for the encryption, so the key that you are going to utilize the encryption will be of 64 bits. In the WEP it was 64 bits, and the secret key was only 40-bit long, and then the IV was the rest of the 24 bits. Okay, so the initialization vector was 24 bits, and then this was 40 bits. Okay, but the problem was that the IV was being shared in the plain text. Okay, so since these 24 bits were being shared in the plain text, this 24-bit is now known to the attacker. But the argument was that since this PSK is not known, so we still have this 40-bit of security. So by using the 64-bit of bits of encryption key, the claim of WEP was not to give 64-bit level security. The claim was to give 40-bit security. Okay, so if they could achieve 40-bit security, which means the probability of cracking the encryption is 2 to the power minus 40, then WEP was fine, but it was not so. And I'm short of time, so I will discuss it again, but I will just quickly take a comment about what could have been the problem here. Okay, so as I said, if with this setup, if you could achieve the security level of 2 to the power minus 40 or 40-bit security, then you would have been fine. Then it would not be called an attack, because anyway this IV is shared in plain text and it is part of the protocol or part of the algorithm. So what could go wrong? So just can somebody just comment on it, that what could go wrong, and then in the next class I will discuss what went wrong. So can somebody make a guess, at least what would have gone wrong so that it is called a successful attack?
IV is used, basically same messages are broadcasted and same IV is used, so we get two ciphertext with the same plain text, some kind of this thing.
Okay, good. Yeah, so good indicative answer that the scenario which may have same messages, scenario which may have same IVs, may have something to do with the attack. So that is very nice. And what could be the impact of the attack? That the level of security or the probability of breaking the encryption would have reduced to some lower value. So for instance, let's say if it go down to to the power minus 20, or not go down, but actually increase to the power minus 20, the probability with which the encryption could be broken, then there is a problem, isn't it? That is what we mean when we say that an attack is successful, which means that the probability which the algorithm claims that the encryption could be broken, and that is what you do not achieve in the real world. You design an attack and you break the encryption with a higher probability. Okay, so if you could break it with 3 to the power minus 20, then you have a successful attack. And that is what happened in the case of WEP cracking, and we will discuss it in the next class. Okay. Yeah, so I guess you can also think about a few things. I will share the slide of about what happened. And okay, so let's discuss some of these things again on Friday. So I don't have anything. So yes, so on Friday we will meet. Yeah, there is no announcement. I already made the announcement related to the project. Okay, so I will see you on Friday then. Bye bye.
Thank you, sir.